taken with an evenly colored background. What it does, it shows, for instance, if you've got a spot on your filter, dust spots show up big, it'll show up. Or if you've got uneven illumination, where your center is all your illumination that falls off towards the edges, the flat will correct for that. This basically, they do some fancy math, and the pixels in the center, they're just averaged on a 1-for-1 basis, and the ones that would be darker out here, they get more of an exposure compensation, so you get an even field. The bias, like I say, that's just zero length, and what it does, it shows up any little dots because you get your pixels. Some of them will go ahead and they'll be excited even though no photon hit them. And the dark shows the same thing. Now, if you get all done with the dark, you may have a bunch of little pixels showing. Light never hit them, but the pixels are excited, so they're pretty well saturated. And again, that gets subtracted. So it's a lot of work, really.
You dark subtract the noise that your camera makes, right?
Well, yeah, dark subtracts the noise, and actually dark will work for both of those to a degree. But yeah, basically it's your noise, and it's a longer exposure. Even with a cool camera, your pixels will start to show up. You'll get what they call a hot pixel, or you'll even get a dark pixel, which nothing happens. But yeah, basically that's what it's for.
Yeah, the silicone will build up a current regardless whether it's been exposed to light or not.
That's correct.
Just due to the vibration of the atoms in the silicone. This is why it's a semiconductor. So the atoms are there vibrating, and every now and again an electron will pop off. That depends on the temperature, which is why they cool the cameras. And so what you do is that you take an exposure, as John said, that's the same length. Ideally, you would take it longer than your exposure and scale it down, but you remove the dark current. In fact, most of the CCD cameras read out the chip quickly to get rid of any dark current that's accumulated, and then start the exposure right after.
And of course, if you spend more money, you get better chips.
Yes.
And they have less defects. The hot pixels are one of the defects that they can eliminate to a degree, but it's expensive.
Yeah.
So that's what. And then finally, when you're all done, you've done all your calibration, and each one of these, you end up with a stack of red, a stack of green, a stack of blue. And the thing is that this is your signal. Each one of these that you go ahead to stack will have that same signal built up in each one, but sometimes you'll get random noise. And if you use average, a lot of the noise will come through. If you use a mean, you'll end up reducing some of the noise, or if you use a sigma clip, basically the noise just disappears. Even an airplane going through will disappear in those. But you keep on adding more and more and more and more to them to increase your signal to noise level. People think that, okay, you take a 1 second exposure, add another 1 second exposure and another one, that you get the equivalent of a 3 second. Really, you get a 1 second exposure. You get a little bit of gain, but not much. The basic thing is you eliminate the noise. You build on your signal, which is a constant each time.